Okay, so we're going to talk about these three skills. Understand, kids. I need you to understand something that Sarah hates when I do it, but like I truly cannot do it in another way. O sea, like if you have two lines in space, o sea, the fact that these two lines can be parallel, but they can be more than parallel. O sea, parallel means that they have the same velocity vector, that they have the same direction. In plane lines, o sea, like in lines in the plane, o sea, my lines can either be like only parallel, which means non-intersecting, o sea, parallel, and that they do not intersect are synonyms. Or they could be intersecting. In space, we have a different definition. O sea, in space, I can have two parallel lines that have the same direction, or I could have something like this. O sea, these two lines, they are clearly not parallel. O sea, as this one is going into this direction, and this one is going into this direction, but they do not intersect. So, in space, if they are not parallel, but also non-intersecting, we're gonna call them skew lines. S-K-E-W, skew lines. Okay, so, for example, if I have two intersecting lines, o sea, two lines that actually touch each other, I can find the angle, the acute angle between them. And to find that acute angle, I only have to do this. Remember that if the angle is acute, then it's gonna be positive, and if the angle is obtuse, it's gonna be negative. But this formula, kids, this formula is not in the formula booklet. Not in the formula booklet, not. I don't want to see any, o sea, because I know you guys. I know what you're thinking. It's like, okay, I'm going to write it down. Where are you going to write it down? Nowhere. You're going to write it down nowhere. This formula is not in the formula booklet. O sea, like, if you have two lines, and B1 and B2 are the direction vectors, o sea, if you do the dot product of the directions divided by the magnitude of the directions, and then you do inverse cosine. This is basically the angle between two vectors. O sea, you're just finding the angle between the two directions, no? You use this formula. It is not in the formula booklet. Okay. Here I have an example. So, look that I am using this from the resource bank because it's a fantastic resource. So I am giving you line 1 and line 2. And so, for example, for this line, this one is my initial position and this one is my velocity vector. For line 2, this one is my position and this one is my velocity vector. So I want to find the angle between this vector and this vector. So to find the angle, I use the dot product. So I find the dot product of my two vectors and I get negative 26. Okay, that means that the angle between those two vectors is obtuse. Now I find the magnitude of each of the vectors. So now remember that the formula that does not appear in the formula booklet says find the inverse cosine of the dot product, well, the absolute value of the dot product divided by the product of the magnitudes, no? Entonces, so it is 26. This number, a ver, give me 1 second. This number is this one. This number is this one. This number is this one, no? So you just do the inverse cosine of those three quantities, no? Multiplying the one in the denominator. And with the inverse cosine, you will get this angle. This one is the easiest from the three skills. Okay, imagine that you have a line and a point outside of the line. Kids, I may ask you to check if a certain point belongs or not to the line. Think about that. How do I check if a point belongs or not to the line? Think about it. I'm not gonna say it right now, but you need to think about it. So I am given that the line, this is my line, and I have this point outside of the line. And I want to find the distance between the line and a point. O sea, I love this type of problems because these problems are, for example, like, if you have an airplane flying and you have like a house nearby, what is the closest distance that the airplane is gonna fly, o sea, closest to the house, no? And o sea, we're looking for this distance. Okay, so what do we do? So this is like, we write this, my line, as a single vector. O sea, and look how I'm writing it. I am writing it like 3 plus lambda 1, o sea, 3 plus lambda, negative 1 minus 2 lambda, o sea, negative 1 minus 2 lambda, negative 2 plus 0 lambda, negative 2. Okay, so that is OF. And now that I have found OF, I'm gonna subtract the position vector of P. O sea, now I found FP. O sea, like, the position vector, this is the position vector 10, 5, negative 10. And I have like my equation vector that is a 3 plus lambda, negative 1 minus 2 lambda, negative 2. And I'm going to subtract the position vector and the vector from my equation to get this guy. O sea, the result of doing the subtraction, o sea, this is my line, this is my point, the subtraction, this guy, is this vector. O sea, it is the subtraction from the line to the point. And what do I want from that subtraction? I want that this subtraction is perpendicular because it will be the shortest length. So I multiply, this is the subtraction, o sea, this is the subtraction, line minus point, and I want the subtraction to be perpendicular to the line. Subtraction minus line is 0. From here, I solve for lambda. Once that I have that, I'm gonna find the point that it's, o sea, well, once that I found that, that will give me like how far away the point P is. O sea, once that you have found lambda, you just plug it in. O sea, plug in inside of subtraction. And because you want the distance, you need to find magnitude, no? So you write as a single vector. Okay, do the subtraction, line minus point. Do the scalar product so that the subtraction and the line are perpendicular. Solve. Plug in the value that you solved into the magnitude of the subtraction. This is the distance between the line and the point. For me, this is a very clear procedure. If you don't want to use this very clear procedure, you can also use, o sea, this is an alternative. You can find a, no, I am not gonna, I don't want you to use this alternative, sorry. Use what I just said. Hee. Okay, now if I have two skew lines, how do I find the distance between those two skew lines? O sea, what is the distance between these two pens? They will never intersect. What is the distance between these two guys? Okay, so I am giving you the two lines. No, I am giving you initial position and velocity, initial position and velocity. Okay, in the same way, I'm gonna write it as only one vector. Each line, I'm writing it as just one vector. Then I am subtracting the vectors, o sea, from each other to find the difference vector. O sea, I write this as a single vector, I write this as a single vector, and I subtract them. So once that I have written like that, I subtract them. Now I do have both letters, no? Mu and lambda. Because they are not moving at the same time. They are moving in different times. And what do I want? I want this difference vector to be perpendicular to this line. And I want this difference vector to be perpendicular to this line. So I set, o sea, from my difference vector, I multiply it times the first line, make it equal to 0. I solve, I solve, and I get this equation that has two parameters. I multiply, I solve, I get the equation with two parameters. Okay, I have a system with two equations and two parameters. What do? I do lean solve. I solve them, and I get that my two parameters are these two guys. Once that I have those two parameters, I plug it into the magnitude of the difference. Again, this 12 is the distance between those two lines. Okay, this is a toughie. Kids, these three things are a toughie. Don't worry. There were a lot of problems for you to practice this. Try doing this. Try doing this. Write them down. It's going to be helpful.